relation between Z and the R, as you can see. That's the shape that I'm telling you about. The cone will evolve inside the sphere. So if you look, that's the sphere. A part of it is outside the cone and the rest is inside the cone. If you look upward, معايا مش كده؟ الكون بيطلع من الوسط فهيقطع منها جزء بتشوفيه الأول as a part of the sphere. ولو أنت طلعت من فوق خالص هتشوف بقية السفير inside the cone. Okay. برضه بيقول describe the following sets in spherical and cylindrical coordinates. Guys, do you remember the spherical coordinates? Do you remember the spherical coordinates? What's the difference between spherical coordinates and cylindrical coordinates? In cylindrical coordinates, the z-axis is the z-axis. But in spherical coordinates, I will add phi, which starts from phi equal to 0 with the positive direction of the z-axis, and it will go to negative pi with the other side of the positive z-axis. So I will be talking about r, theta, and the phi. R run from 0 up to infinity. Theta run from 0 up to 2 pi. And the phi from 0 up to pi. From 0 up to pi. Those are the limitation of the spherical coordinates. And of course, the relation connecting them. So he wants you to describe the shape, which is x squared plus y squared plus z squared less than 2 and greater than or equal to 1. What do you think? What's going to be the shape?
Sphere.
حلو جدع 100 بس actually those are two spheres inside each other. I'm talking about the points which is outside the sphere, which radius is, but inside without the outer sphere. Okay, the bigger sphere, which was z equal to 2. So you have a smaller sphere with radius 1 and the bigger sphere with radius 2, and I'm talking about the part between them. Can you imagine it? Okay. And not just only this, I'm talking about the cut where z is greater than or equal to 0, so it's an upper part. And y is greater than or equal to 0, so it is a quarter. Then for x is greater than 0, so it's a 1/8 from the space. So actually, I'm talking about a very specific shape. It's a 1/8 of the inside between two spheres. One of them R1 and the other R equal to 1, and the second R is equal to 2. Can you imagine what I'm talking about? Okay. I will try as much as possible. This is one of the spheres. I've chosen a part from the space where you can see it is the outer surface of the sphere. It is the outer surface of this one, greater than or equal to 1. So it is outer space. This is why you see all of this solid, because inside is not with you, but outside is with you. Then the inside of the other sphere, that's the other sphere, which is greater than or equal to 2. So actually, I'm talking about the thickness between the two spheres. So I'm talking about a hollow sphere of radius 2, but with thickness 1. Okay? Huh? If I got the cross section, you will have the ring. So if I cut it, I will have the cross section of, that's the first circle, which is the smaller sphere, and that's the outer, which is the bigger sphere. Can you imagine it? This is the part that I'm talking about. So it's a hollow sphere, but with thickness equal to 1. معايا يا شباب? Okay, very good. So that's the shape between the two spheres, as you can see. And if you go up, remark that I'm talking about the upper part, z greater than or equal to 0. Are you with me, Mr. Seda? And with y greater than, so the first one I'm cutting into a semi-sphere. Then the second regulation, y is greater than, so it's gonna be just only a quarter of a sphere. معايا يا شباب? Then the third regulation, when x is greater than or equal, so I'm talking about 1/8 of this sphere, or 1/8 of this space. معايا يا شباب؟ This is where x is greater than and so on. So now I will put by the idea, the representation of a sphere, in 3 dimension, it will be r square plus z square equal to 1, that's in cylindrical. X square, y square, z square equal to 1, that's in Cartesian. But the beauty of having a sphere in spherical coordinates, it's gonna be just only the rho, the radius. So actually, the representation of the inner part between the two spheres is just only rho less than 2 and greater than or equal to 1. That's the representation of the inside between the two spheres. Are you with me? That's the advantage of knowing the Cartesian, the cylindrical, and the spherical coordinates. Some shapes in cylindrical, in Cartesian, or dealing with cylindrical will be easier than Cartesian. And in spherical, like this one, it's going to be easier in all of them. But remark, the advantage that you took in the rho or in the radius, you will have to pay for it for the relation connecting the x, y, and z. So once more, I will go for z is greater than or equal to 0. What's controlling all of this? Theta and phi. So z is greater than or equal to 0, I'm talking about the upper part. The upper part of the space, it's from phi, because phi will be measured. Phi is equal to 0 in here, and will increase till phi is equal to pi over 2. This is why it's running from 0 up to pi over 2. I'm talking about the upper part. وفاي بتفتح من عند الزيرو، من عند زد بوزيتيف، وتبدا تشتغل كده عند باي اللي هو الاكس واي بلان، بعدين تنزل لتحت تديك النيجاتيف زد. زد بوزيتيف في الفتره بتاعت فاي from 0 to pi over 2، ونيجاتيف from pi over 2 up to pi. Okay, so that's the value of phi which controlling this issue. I will now need to deal with y is greater than or equal to 0 and the x is greater than 0. So y is greater than or equal to 0, it will lead that theta is running from 0 and up to pi. And in order to satisfy that ex is less than, is greater than 0, so I'm talking about this guy only, which means theta is running from 0 up to pi over 2. Now I can rewrite the limitation. I'm talking about spherical coordinates, which will appear into rho, theta, and phi. Rho runs from 0 up to infinity. Am I right? Theta runs from 0 up to 2 pi. Yes, we are right. Phi, it's from 0 up to pi. For the specific shape, this is all written in here. For the specific shape that we are dealing with, I'm dealing with rho greater than or equal to 1 less than root 2, because here I have rho squared. So the actual relation in the radius is rho greater than 1 and less than root 2. And those are related to the relation of the theta and phi, as you can see. Here's phi is greater than 0 and less than pi over 2. So I've described the shape, I've determined the shape, either in Cartesian or in spherical coordinates. Please, I want you to think, in order to determine or to describe this part in space, do you have any other idea how to describe it? يا شباب بالعربي، الشكل اللي انا بتكلم عليه اللي هو تمن كورة محصورة، تمن كورة محصورة بين الكورة اللي الريديوس بتاعها 1 والريديوس بتاعها 2. متخيل الشكل؟ انا بتكلم على تمنها. لو انت تخيلت كورة، وطبعا الكورة دي لو هي السنتر بتاعها الاوريجن معايا، بس لو السنتر بتاعها متحرك سنة عن الاوريجن، يبقى التمن مش هيبقى تمن كورة، ده هيبقى تمن من اليبسويد، مش كورة بالظبط معايا، لانك حركت اكس وواي وزد. فكر في طريقة توصف بيها اللي انا قلته. Think clearly how to describe for someone the position exactly of this shape. You will never find more than beautiful way to just describe it other than this, either in spherical or in Cartesian. Are you with me? Cylindrical here, it's not gonna be that easy. Okay, Look to this problem also. That's another description of having x squared plus y squared over 2 greater than or equal to z, and that's a representation of what? Of a cone, and z is greater than 0 and less than 2 also, which represent a parts relative to z. From z equal to 0, it's a plan, and z equal to 2, it's another plan. So once more, these are the relation of the spherical coordinates. Now I have rho from 0, blah, blah, blah. Okay, if I want to describe this equation, for example, I will have that z is greater than 0, less than 2. This is going to be controlled by either rho or phi, okay, in order to get this issue solved. So I will replace z with its relation, which is r cosine phi. That means I will have r cosine phi greater than 0, less than 2. Rho, I can divide on it. So once more, I will have the relation of rho cosine phi less than 2. And then I will do a replacement here of z squared, x squared, y squared by the other relations. بص كده فريد. Replacing z squared is going to be rho squared cosine squared phi, which is less than or equal x squared, that's the relation, and that's y squared. If you look inside these equations, I can take common factors and simplify my life. How it's going to be simplified? First of all, I can eliminate rho squared, rho squared, rho squared from all of them. If I took sine square phi as a common from this part, the first part and the second part, I will have, okay, let me walk you through it step by step in order not to lose the way. Okay, this is going to be rho square, cosine square, phi less than or equal. Take rho square as a common. Actually, no, take rho square, I believe, sine square phi as a common. From this part, it's going to give you cosine square theta plus sine square theta. As you know, this part is equal to 1. And all of this is divided by 2. I can also eliminate R2 with R2. Now I have cosine square phi less than or equal sine square phi over 2. I think I can get to tan square phi is greater than or equal to 2, which means I have tan phi, which is greater than or equal to root 2. Am I right? صح? That's the deviation step by step. We are very happy today to have you, Mr. I've asked about you all day long, and Ziad told me I don't know what she is. Okay, so once more, taking rho as a common and trying to simplify it as much as possible. That's the relation connecting the cosine phi and sine phi. This is going to be in a similar case as exactly as I did with you, which is tan phi is greater than or equal to root 2. So now I will be able to control the angle of the intersection relative to the z. So once more, it's rho theta and phi. Rho is from 0 up to infinity, from 0 to 2 pi, and theta from 0 to 2 pi, phi from 0 to pi. The first relation, which states that rho is greater than 0 and less than 2 of sec phi, which is actually, we got it from the relation connecting r squared, and this is going to be rho from this guy. I have here 0 less than rho cosine phi and 2. So I can simply put it on this form in order to get the value of rho. So rho is less than 2 over cosine phi greater than or equal to 0 by dividing on cosine phi and away from the 0 point. So that means rho is greater than 0, less than 2 of a sec of a phi. This is the first part. And, of course, and with theta greater than or equal to 0 and less than 2 pi, because I'm talking about the whole space, and with the regulation on phi running tan minus 1 root 2 and the phi is less than or equal to pi in order to be able to work with it. This is how to represent in spherical coordinates this equation. By the idea, that's a standard problem. Those are standard problems that you will face in your first midterm. You will have questions about the coordinates about the sectors, the sections related to all of this. Okay, I believe this question is very nice, and I believe it was something like this was in the previous exam. I want you to remember, I'm talking about spherical coordinates. So in spherical coordinates, what's going to be the case if phi is equal to 3 pi over 4? Do you still remember the spherical coordinates? How the spherical coordinates are built? Huh? If phi is equal to certain value. Okay, once more, because Miss Sulai is joining us today. X, Y, Z. When I talk about spherical coordinates, that's R. R, it's running from 0 up to infinity. And that's phi. Moving from phi equal to 0, positive z-axis, and to go all the way to the negative z-axis, z negative, which will happen at phi equal to pi. And in order to cover the 360 in the xy plane, I will have theta running from x up to the negative side of x. So theta is greater than or equal to 0, less than or equal to 2 pi. So what we mean about phi is equal to 3 pi over 4. It means that you will leave z by this 3 pi over 4, or on the other side, whatever by the angle. But this angle is free from the other two dimension, so it will be moving. So imagine that I have the 3 pi over 4, which is pi over 4, it's going to be 135. So imagine that's the positive z-axis. The r is running from 0 up to infinity, and it can go around in 360. So imagine I'm moving this arm till phi coming to 135. Can you imagine it? And then it will move. This arm will move from 0 up to infinity, and it will move 360. What do you think the shape? It's gonna be a conical half, apart from a cone, going downward. Are you with me? Oh, then once more. Z will be opened till you have this arm. And this arm will move in 3 dimensions. So actually, you will have something like this. That's the cone that I'm telling you about. Okay, it's a part of a cone that's around 360 or around the z-axis. So once more, when phi is constant, r and the theta are free to move. In this case, you will have a conical shape. So once more, here we go. This is phi equal 135, that's 3 pi over 4. So if you use the relations, okay, those are the relations in order to remember the relation connecting from spherical into Cartesian or vice versa. Okay, that's the shape in general, okay, but not in this case. That's the shape. If phi is constant, you will have a cone. It will depend on the value of your function, on your phi. This is the shape of the cone if phi is less than 90. معايا فريد؟ بجد معايا ولا؟ طب اعملها ازاي؟ This is R. This is R. That's the origin. That's positive Z. That's negative Z. So this is R. I'm holding R right now. From 0 up to infinity. Am I right? Okay. If theta equal 45. So this is phi equal to 0. Phi will increase. This is how phi increases. Phi will stop at 45. This is 45. So I will try to imagine the shape. Okay, I will move. The line is drawing something. Look at the something that I'm doing. When I'm leaving, I'm following like this. It will be a cone. Am I right? Actually, it will be this cone. That's the line that I'm telling you about. But 135, it's not going to be represented by the upper part of the cone. No. The phi will be, once more, it's 0. It will be open. Till it reach 135, that's the angle. Phi, from 0 up to 135. Imagine that I'm leaving like this, or around 360. It's going to be the upper part of the cone. Okay? So, once more, if Z is equal to R, if I made Z equal to R, but I am leaving phi and theta are free. If Z is equal to R, it's gonna be, here we go, that's gonna be a sphere. Because you will have that arm, okay, you will have that nice arm, okay, but it has the privilege of moving 360 in every direction. I'm sorry, 360 round, and from 0 up to y in every direction. It will draw a sphere. Okay, what will happen if theta is equal to 3 pi over 4? Theta instead of phi. So once more, that's the space. Okay? Theta runs from the positive direction of x, that's the positive direction of x. And it will move, here we go, it will move 360. This is how theta moves. Okay? And the r moves like this. Okay? From 0 up to infinity. And the phi controlling from 0 up to pi. So imagine at theta equal to 135, this is theta moving. It will come and stop right here. That's theta. Okay, that's the positive direction. So it is greater than 90, stood like here. And the r is free. R can go from here up to pi. And this is phi. And the r from 0 up to infinity, positive infinity. In this case, it will be a plane. So just imagining how they are moving r, phi, and theta, either in spherical or in cylindrical coordinates, it will give you the shape that you expected. So once more, for this guy, it's going to be the cone that I told you about. And that's the r that we are talking, the angle, I'm sorry, from z positive. This is the angle which is 135. Okay, if I'm talking about z is equal to r, it's gonna be z equal to r in spherical coordinates. It's gonna be, as I told you, just a second. This is in cylindrical coordinates, I'm sorry. In spherical coordinates, it will be the sphere. But if I'm talking about theta in spherical coordinates, which is 135, it's gonna be the shape of a plane exactly like the cylindrical. So that's theta equal to certain, that's rho equal to a certain value, and that's the phi. By the end of this slide, طبعا دول الدescription بتاع الangles, just making the substitutions in the relations. By this problem, now you have, I've solved plenty of problems covering this part. And I've shared on the YouTube all the details, the detailed videos covering this part also. From the polar, from the cylindrical, from the spherical, and so on. Now I will move to another topic. And remark, our course is very delicate. It started with the names. This is why if you didn't attend from the beginning or you didn't study from the beginning, please start from the beginning. You will know the names and the equations and how to draw them. So it will make your life a lot easier. Then we went through coordinate systems with the relations connecting all of them together. Then we had plenty of problems, tons of problems, covering how to move from cylindrical into spherical, from spherical into cylindrical, and so on. And Cartesian, of course. Now I will talk about another issue, which is really very important. It's the core of all of this. And all what we studied before, they are tools that will be used down the road. This time, I will talk about real functions of several variables. In order to cover this, and I believe it will make your life also a lot easier. How many types, Ziad, of functions do you think do we have? We have functions, and it's related to linear algebra. We have functions that are running, say, and fatten from R into R. And in this case, I'm talking about the functions. Those are functions running from R into R. So it's a one variable input and one variable output. The first R, ya Farid, the first R stands for the domain. The second R stands for the range. So I have function in one variable. I'm entering one variable and I'm expecting to receive one variable. This is a function, Ms. Fatin. Do you think this function in how many dimensions? From R to R? 2 dimensions, yes. It has 2 dimensions. So actually it will be represented in 2 dimensions. Right, Mr. Farid, I will talk about the case of functions in several variables. And in this case, I will be negotiating with R to the power of n into R. So it is the case of having R2 into R, or R3 into R, or R4 into R. So I'm entering variable coefficients and I'm receiving just only one output. So if I'm in R2 into R, the services that you will have, it will be in 3D. That's the representations that we saw. It's the beginning of having a sphere, of having a paraboloid, of having whatever the shapes that we have been dealt with in the previous sessions. And also we will have functions or vector valued functions where you are working with Rn into Rn. So you have several inputs and you have several outputs. And in this case, say that the representation of this guy, it's gonna be n plus m dimension. I usually add the domain and the range in order to draw or in order to imagine. Are you with me? So those are the 3 types of functions. Now we will try to deal with, we already covered, most of us know a lot about the R and R. I'm going to talk about R2 into R or functions in several variables. The applications is in every field of life. Everything, whatever you can imagine. In your kitchen, in your sleep, in your walking, in engineering, in whatever. All the relations between anything in your life or in our lives, it's functions in several variables, in the general case. Let's take this example, which is an example of an area. How to evaluate the area of a rectangle? Farid, how to get the area of a rectangle? Actually, I will write the length times the width, which means I will have 2 variables. Multiplying them together, I will have what's called an area. So it's a function in several variables. Actually, it's running from R2 into R. The length and width are the input, the output is the area. So he started from this, the area of a rectangle of length C and width L is given by A is equal to IC. That's the function which represents the output, which is A, the input, which is I and C. So that's a mathematical representation. It's running from R2 into R. Are you with me? R2, 2 variables, into R, which is the area. Okay. Also, I can write the domain, which we are changing the 2 inputs, and both of them are lenses. So the domain will be R positive times R positive. Okay? So it will run from R positive cross R positive, that's for the domain, and for the range, it will be also running to R positive from 0 up to infinity. So also for the range, it will be from R0 up to positive. Also, another application, if you try to find the arithmetic mean, you took statistics, of course, previously, and you will take more. One of the famous means, I have geometric mean, I have arithmetic mean, I have a lot of means. But the general case, the simplest one, is the arithmetic mean, which is simply the sum of the variables divided by their number. So if I have from x1 up to xn, those are all input variables. The output just only one. So it's a function in several variables. Okay? So once more, it is f, the value of x1, x2 up to xn, and the input is x1, x2 up to xn, and that's the relation connecting these several variables. The input will be, the domain will be x1 up to xn belongs to Rn, and the output will be Rn. Okay? Function domain, in general, those are the conditions. I'm talking about the domain, so I'm talking about the input, the range, I'm talking about the expected output. It's described in here. Already we covered this through our negotiation at the time being. The domain is called, it's actually, any function can be represented by the independent variables, which are the input variables, and the dependent variable, which is the output of your function. So also it's exactly the same. Through analytical expression, we have two situations in order to get the domain. Either the domain is given explicitly, like the general ones, or it is the natural domain, which consists of the set of points for which the analytic expression makes sense. This is really very important. Because if I want to get the domain of a function in several variables, or I will have to be sure that your domain is delivering values which we all know, we can find. Which means you will have to avoid the values that will make the denominator equal to 0. Or the values that will make an even root, okay, or an even radical be negative sign. Or to avoid 0 or less than 0 or negative numbers in the logarithmic function. All of these are limitations, okay? So those will be controlled by this one. Graph of real function of one real variable. This is where you know that if I'm talking from R to R, I will be working with 2 dimensions. As I told you, this is if the domain a subset from R, and the range is going to be a subset from R. So simply, I'm talking about an input of one variable, the output of one variable. So I'm talking about 2-dimension case. That's the case of y equal to x squared, y equal to ln x, y equal to root of x, and so on. Okay, if we move further to functions from R2 into R, I will be talking with surfaces in 3 dimensions, like the sphere, like the paraboloid, like the other surfaces. Okay, determine the domain of this function. So it's another part of the questions that you will be subject to in your exam. The first is about the coordinates, determining the intersection. The second will control how to describe the domain, the best way to describe the domain. So, Ms. Fatin, let's look to this problem. If I want to find the domain of this equation, or I'm sorry, of this function, how to get the domain? Any ideas? What's the limitation? What's the limitation? Ziad, what's the limitation? For this function, in order to get the domain, I will have to have 1 minus x squared minus y squared greater than or equal to 0. That's right, let's say that. So the first step to do something like this, I need to be sure that 1 minus x squared minus y squared is greater than 0. Why I must say that? Because simply I have log. So those numbers represent what, Mr. Farid? ده بتاع ايه يا فريد؟ ده مين ده؟ Inside of a unit circle. You're right. So this is actually x squared plus y squared less than 1. And x squared plus y squared less than 1, it's the circle. Okay, can you describe this circle in simpler way? Yes, r is equal to 1 in polar coordinates. Am I right? So once more, this is x squared plus y squared less than 1, which can be written in polar r squared less than 1, which means r is less than 1 in polar coordinates if I want to use polar coordinates. So once more, the domain of f is the set of all xy that lie inside, but not on the unit circle. Why not on the unit circle? Because the log reject the 0. The log reject the 0. Okay? So once more, this is x and y belongs to r squared, such that x squared plus y squared less than 1. If I wrote less than or equal to 1 in other situation, يعني if I have, instead of the log, I have square root, this is gonna be less than or equal. So the boundary of your circle will be involved with you. How to get the range? How to speculate the range? Those are the input values. So the range will be shaped like this. This is gonna be y equal log of an x. The x here stands for the points of the circle. So actually, this is the circle, and that's the part, the outer part of your the range. So if you imagine this is the part of the logarithmic function that I'm dealing with, and I'm talking about the points inside the circle, so it will give you a part of something like a paraboloid looking down. If you imagine, look to this part. If I make this part just moving around in 3 dimensions. So actually, if I want to do this, all I have to do is to change into polar. So I have log 1 minus r squared, where r, as you can see, and the r, of course, from 0 up to 1 from this regression. So the second step, r equal to 0, when r is equal to 0, it's going to be log 1 minus 0, which means log 1 equal to 0. It will start from 0. And then approaches the boundary of the unit disk, which is r is equal to 1. It means 1 minus x1 squared equal to 1. And hence, it will give you up to negative infinity the shape of the log function after applying the log. So all the points inside, as I told you, inside your circle as an input will deliver this shape. That's exactly the shape that I told you about, the movement of this part around itself. Okay? So from the point of till r is equal to 1. So that's the shape. Okay? The shapes are not going to be required from you, just only the equations, but it will make you will have better understanding of what's the shapes that will be delivered. Okay? So that's the shape as I told you. Graph of real functions of several variables. We can graph from R2 into R.